Our next method of finding limits is more of an estimate, not as much of a surefire way to get the perfect answer, but it does get us probably in most cases very, very close. This is something that can be used for most limits, and like I said, it's not going to give you an exact answer necessarily, but it gives you a really good guess. Now, just first of all, looking at this, like any of these problems, we want to see if the direct substitution method works before anything else. We've got as x approaches negative 2. If we plug in negative 2, that means the denominator is 0, so again, that really doesn't work. But what we're looking to do for this limit is, let's use this graph that you see here. This is a graph that was created by a calculator, and the pixels make it look like it doesn't have any breaks or gaps. But we're going to be looking at x equals negative 2. So at negative 2, I'm just going to draw a dotted line to indicate that this is the x value that we're looking at here. Now, apparently when we are at negative 2, this doesn't have a value, but if we look on this graph and just kind of connect the dots, it looks like our point would be right there if there was one. So now looking at the grid that we see here, it looks like we've got 12 as our y value on that one. So I would submit that the limit here, just by looking at this graph, is going to be at least really close to 12, if not exactly 12.